regarding buffer overflows, underflows, or anything that has to do with the actual implementation, software implementation of those protocols. And the last one is the architectural issues that we have, the ability of somebody trying to access the call manager or the SIP proxy from the corporate data network into a remote site or the VoIP network. So with the attack categories here, we have service disruption against the phones, the protocols that support those phones, and we can affect edge devices or any core network elements. Unauthorized access, we have a number of components that can be affected, from DNS servers to management components to provisioning components, and billing systems in the case of a carrier. Eavesdropping and traffic analyses are traditional type of attacks that we've seen in the past, and we're going to be discussing eavesdropping and traffic analysis in the case of ZRTP. And for those who were not here earlier, Phil Zimmerman presented the strengths of the ZRTP protocol, which works, by the way, and there's a lot of support by the ITF community and generally everybody out there to adopt the protocol. But as everything else, there are some weaknesses that people might take advantage of, and we're going to be discussing one significant weakness. And fraud is, as we said before, something that pretty much reflects or concerns carriers and to a lesser extent, enterprise networks. Okay. So now we're going to start looking at the MGCP protocol. So the MediaGate protocol was developed with the idea to support signaling, to support the interconnection between edge devices or in some cases between a call manager or a proxy or a gateway and a PSTN type of media gateway. And is used in many implementations out there as the interconnecting protocol. Some of the attacks that can occur with by manipulating the MGCP protocol include remote eavesdropping, which we're going to discuss, call diversion, call disruption. The next subject, as we said, is ZRTP weaknesses. And then we're going to touch upon a little bit presence hijacking and caller ID spoofing. So MGCP was developed by ITF RFC 2705. It listens on ports 2427 for communications between a call agent to a gateway, and a gateway to call agent uses 2727. Here we have the message structure of the MGCP. And the reason I have this is because you will need this to understand a little bit more about what we're going to be doing when we start talking about the attack. So in this case, initially we have the command, if you will, of the protocol, the transaction ID, and the endpoint, and then the version. This is the first line that is present in every message in the MGCP. And then some additional information that is being carried to provide specific configuration information for a specific endpoint. Typical deployment of the MGCP occurs, as we said, between a call manager or an intermediate component that acts as a call agent or a call manager and the signaling or media gateway. So I've seen one implementation, a carrier-based implementation, that is using MGCP between the edge device, the core network, and the PSTN. So you can use MGCP also as a protocol between the edge device and your core network, but the choice is typically HTTP3 or SIP. So when we start talking about the attacks associated with MGCP, one attack that is possible is to reroute RTP traffic. And in essence, what you do is you manipulate the signaling messages of an MGCP gateway and you reroute media traffic to you, the attacker, or the auditor, or the consultant that does the assessment. So basically, you have to have knowledge of the MGCP protocol. And the idea is you traditionally have an association of the edge device and the call manager. You might have SIP here or H323 or Skinny, whatever the case might be. And then, as we said, the MGCP between the call manager and the PSTN gateway. Typically, when a call comes in to the network, the MGCP gateway talks to the call manager locates the user answers, and the call manager says, okay, Mr. Gateway, set up a channel so-and-so to start routing RTP. Now, in some implementations, RTP may be routed through the intermediate component. In most implementations, it's not. So we have the RTP being routed directly from Bob's phone to the PSTN gateway. So the signaling may go through intermediate components, but the RTP is end-to-end. So with this attack, what we're trying to do in essence is we send specific MGCP messages that say, instead of sending the traffic to Bob, why don't you send it to me and I'm going to reroute it to Bob. Now, at this point, the MGCP, any MGCP implementation, does not have the intelligence to say, well, I've been talking to Bob for so long, you're not authorized to do this, I'm not going to let you do it. And that's not the case. So that's a protocol specification weakness that we need to address. And we're going to discuss as to how we're going to need to address that. So if the ports are open and MGCP is used, I'm able to reroute RTP traffic through me back to the user, or in some cases, because this can be a little bit complex and you have to know some of the port numbers being used, and we're going to see how you can get those between the edge devices, the RTP port numbers. What you can do is you can use the same type of attack to eavesdrop into conference calls. Because in essence, if you break this connection, the end party is not going to receive RTP anymore. But all the other parts that are connected on the same trunk, you're going to be able to receive that type of traffic directly to you. So the steps for this type of attack are as follows. First, we have to identify what channels the gateway has active. Then we have to interrogate each channel to see specific information, connection IDs, SDP information, which we'll discuss. And then to audit a specific connection, and then we're going to do the rerouting, the actual attack. So when we go through the first step, the attacker request, it looks like this. Audit endpoint, the ID of the request. And over here with the asterisk, I indicate that I want to audit all the endpoints on that gateway. So in essence, I'm saying, show me what you have in terms of active connections. And the gateway's response is, I know about all these endpoints. So the next step for me is, okay, I know that you have all these endpoints. What I'm going to do is I'm going to send an audit endpoint request, which pretty much says, audit this endpoint, the specific one, and just I use a combination of different options here to have the gateway respond to me with the right information that I need in order to complete my attack. And the right information, the most critical one, is the connection ID that we see here. And then the other is the association with the respective call manager. So when I send the audit endpoint request with my options such as information, the endpoint, other endpoint configuration information, the response that I receive is, okay, for this endpoint, there's one connection, active connection, here's the ID, and it talks to this call manager. So in essence, what I've done is I know that this person is talking on the gateway, and I know which call manager is being used for that communication. So this is part of your traffic analysis. So as we go forward, the next request is to audit a specific connection. And then since I have the specific connection ID, I send another request, audit connection with ID such and such. And the response that I receive is this beautiful set of instructions or headers, if you will. Now, there are two protocols here. The response includes the MGCP protocol up to here, And then there is what is called the SDP protocol, the session description protocol over here. The session description protocol captures the information that I need in order to finish my attack. Over here we have that this specific endpoint is associated with this telephone number, or not telephone number, IP number that is corresponds to an IP phone, Cisco phone, no matter what the phone is. And the RTP traffic is sent on port 18688. So I know the IP number and I know the port number of this connection. So what do I need to do in order to go forward and try to reroute the traffic? So let me, hold on a second. Let's see. All right, for this, we should have some audio. I don't know, do we have the audio on? Yeah. All right. I may have to come back to that. But basically, let's make this. Yeah, we don't have the audio. So the idea is that we send across a set of instructions to the MGCP, and those instructions capture the following, which is modify connection, MDCX, with my ID number for this specific channel. Then there's a connection information that are retrieved along with the connection ID. And this information it's somewhat relevant and it's pretty much standard. So the important point here is over here I indicate where I should send, or the MGCP should send the RTP traffic. So pretty much I'm saying modify this existing connection and send it on this port using this IP address. So automatically all the RTP traffic will be routed to this IP address and this MGCP, or in this RTP port.
Hey Jeff, sorry about the long delay. You wouldn't have believed this day. I would prefer to actually take that span down and then bring that span back up. Are you familiar with the commands for doing that?
For further verification, may I please have the month and day of your date of birth?
Thank you for calling the business bank you'll like doing business with. If you know your party's extension, you may dial it at any time using the number 5 plus the existing extension. For a company directory, please press pound.
So this is the result. Basically, this was a capture of conversations that resulted by doing this type of attack, or rerouting RTP and between the MGCP gateway and an attacker. So when we had this connection back and forth, the attacker sent those commands, the MGCP commands, and he was able to, or she was able to reroute the traffic and collect the RTP traffic and decode the RTP traffic. There are a few tools out there. Wireshark is one tool that allows you to look at RTP traffic, decode it, and listen to the stream in 3 easy steps. So this pretty much captures the attack. And